All right. Okay, so we're going to be covering area, perimeter, and circles. This is going to be kind of like what you need to know so that you can understand everything in the rest of this course, just because these are like the fundamentals.
Yeah, also, since I know a lot of you probably already know what like area perimeters, and even if you don't, it's not really hard to like learn about it. So hopefully today we can like spend some time going over some like real problems, like AMC problems, and I think there's like a couple of math problems thrown in there too. So
Yeah. So if we go through area and perimeter, which are pretty simple topics, if we go over that quickly, then we can spend some time on some trickier, but also, in my opinion, more fun questions from real competitions.
Yeah, okay. And basically for the class competition, we're going to be giving out points for when you answer questions, explain questions, or just ask us questions. So you get points for asking us questions.
Ask us like good questions. I'm not like ask us like what's 12 plus 12.
Yeah, you know? Those don't count.
Yeah, like genuine like questions that make me like think.
Yeah, and of course bonus points are given out freely, and winner will get a free virtual popsicle, or if you're not satisfied with a virtual popsicle,
you can get like a virtual cookie. If you want a book, I don't know, I'll try to get you a book.
Yeah, basically, if you don't want a virtual popsicle, just ask for something and we'll see if we can
last week GoPal was trying to give out like a gift card. We're probably not going to do that because I mean, we don't have money. So
okay, so yeah, first topic is area. So basically area is just the amount of space a shape takes up, and it's expressed as like square units, inches squared, feet squared, etc. So most shapes have a straightforward area formula. However, usually in competitions, they won't be asking you just for the area. It'll be a little bit more trickier, and they won't give you all the information needed to find the area. So
a lot of times you also have to use combinations of formulas, like use 3 or 4 formulas in like one problem to try to find the area of a more intricate shape.
Yeah. Okay, so let's just go over some basic formulas first. So to find so basically a rhombus and kite, they have diagonals. So the area of a rhombus or kite is 1/2 times the length of both diagonals. Yeah, Rashad, we can alternate.
Okay, yeah. Okay, so triangle. Triangles probably, it's just half. Well, if you notice, the triangle is kind of like half a rectangle. So the area is going to be 1/2 times the base times the height. So a triangle, typically, you're not going to be using the more basic formula just because they're going to give you like limited information and stuff. But yeah, 1/2 times the base times height.
Yeah. Rectangles, pretty easy. Length times width. I have nothing else to say about that except that sometimes generally the questions won't be like directly asking you for the area as the answer. It's just usually the area is a stepping stone to that answer. And a question?
We have a question.
My question was like, for the rhombus and kite, what does the D1 and D2 stand for?
Oh yeah, those stands for the diagonal. So you see, wait, let me change my color. So you see these lines. So this is still a diagonal, and this is another diagonal. So the area is 1/2 times the length of the first diagonal times the length of the second diagonal.
So how do we find that?
Yeah, if you think about it, this is the area for the formula for the area of a triangle, right? It's 1/2 times base times height. And if you notice, a rhombus is actually just 2 triangles. So this is basically just the area of a triangle, except it's like extended on both sides. So
did you mean how to find the diagonals? Like,
yeah.
Well, sometimes it'll be given. Other times you're gonna have to use Pythagorean theorem, but we're gonna go over that in more detail in
the next class.
Yeah, later. Yeah, but good question.
Yeah, that's a point, I think.
That's a point. Yeah, I'll give you a point for that.
Yeah, so Yeah, sometimes they'll give you the length of the diagonal, sometimes they won't, and in that case, we'll hopefully teach you some methods to find them.
Yeah, we'll teach you how to figure stuff like that out.
Okay. And
Parallelogram is area equals base times height. So there's actually a very neat proof for this. If you take the triangle, like I don't know if you can see it, but at the very end, there's a right triangle. If you take it and if you move it to the other end, what Amy's drawn, like you just like cut it out and you just shift it over, it forms like a rectangle. I don't know if you can visualize that or not. Yeah, so if you take it, you just move it over to the left, then it makes like a rectangle. And so from there, we already know the area for the rectangle, and that's length times width. So it's just base times height.
yeah. Okay.
Can you go back to the
Continuing.
slide for 1 second?
Okay, yeah, sure.
Thank you.
For a rhombus, can you do base times height as well?
No.
Actually, yes.
Well, for some
because a rhombus is a parallelogram, but you can't do that for a kite because a kite is not a parallelogram.
It depends.
Okay.
So if it's a rhombus, then yes. If it's a kite, no.
What's the difference between a
A
rhombus and a
rhombus
kite?
has parallel sides, and a kite does not necessarily have
This
parallel.
would be something like a kite.
Yeah, what AB drew is a kite, so you can see that they're not parallel. You can't use the area of a parallelogram for that, but you can use it for the other image that's already there. Yeah. Any other questions?
Base times height for rhombus, but not for kite.
Yeah, but we recommend using D1 times D2 divided by 2. Because I mean, then you don't really have to think about the 2.
Yeah. Any other questions? Okay, so area of a square is a rectangle. So rectangle's base times height, which is just a square, except the square has 4 equal sides. So it's just the area is just the side length squared.
Yeah. All right, trapezoid. I would say of the ones we're covering, this is probably like the most, like the hardest one to memorize. It's not that hard once you get used to it. It's 1/2 times base 1 plus base 2. So Amy will show that what base 1 and base 2 are. It's just the 2 parallel sides. Like, so that's base 1, and then that's base 2. And then, so it's base 1 plus base 2 times the height, all divided by 2.
Yeah, and where this formula came from is that if you cut off this part and then flip it up here, again, it sort of becomes a rectangle. So then we divide by 2 to just reduce it down to just one side. So it becomes this rectangle.
Yeah. So 1/2 times base 1 plus base 2 added up times height.
So why can't we do like length times width then? Oh, never mind. But I have another question. Why do you divide by 2? Like you said, like it becomes a rectangle and you divide by 2 because of that? I don't get it.
Yeah, because the base one is this part, right? But if you cut off this triangle and move it to here, then what happens is that this base 2, part of the base 2 stays down here, but part of it goes up here. So that means the base 1 plus base 2 is actually 2 lengths, not 1 length. So we have to divide by 2 to reduce it down to just 1 length.
Yeah, because in when you're finding the area of a rectangle, you're not doing 2 times length times height. You're just doing length times height. So when you're moving it, you're actually getting 2 lengths. So that's why you have to divide by 2.
Yeah.
Okay.
I mean, could you also like one kind of way? Could you also just like calculate the triangles and also the base?
Yes, you couldn't calculate them individually. All right, next.
Okay, and finally we have the area of a circle, which is the radius of the circle is the distance from the center of the circle to the edge of the circle. So it's this line right here. So that's the radius. So the area is pi, which is approximately 3.1415 times r
You don't need
squared.
to. You don't need to know that
Yeah.
pi. Well,
Generally, as long as you just write pi, that's fine. You don't need to actually multiply it by 3.
yeah, like
0.14.
if the radius is like 2, you can just do 4 pi.
Yeah.
I think you should know that pi is 3.14 or pi is 22/7. Just because sometimes AMC will ask you, you know, like like sometimes you maybe have to multiply 4 times pi. Just a simple calculation like that. Which isn't too hard. That's like what,
Wait.
4.56, I think. No, 12.56.
Is 22/7 like exactly what it is, or no?
No, but
Not
it's
exactly.
very close. Like very, very close.
Yeah, so it's good as an approximation.
Yeah, it's 3.1415, and pi is like 3.14159265, I think.
Yeah. Okay. And finally, we have a sector of a circle. So first of all, a sector is like a slice of a pie. So you have a circle, and the sector is like if you take a piece of pie out of it. So so this part would be a sector. Also, this part down here, that's sort of like the opposite of that little
It's
slice
also
of pie.
sector.
Yeah, that's also a sector. So you
It's
can
just
think of a sector as a wedge of a circle. So
So, okay.
you can go.
Yeah. So essentially, you're gonna take the total area of the circle. So pi r squared, right? And then you take the degree of the sector that you're trying to find. So circle is 360 degrees, right? So let's suppose the degree is theta. Theta is like, actually, I think we should just do it. Like, yeah, so theta. So theta is
This is
just like a
theta.
variable, okay? That's theta.
It looks like a pill.
Yeah, it's a Greek letter. It's just a variable. So let's suppose the degree of the wedge is theta. So then we would just do theta over 360 to find the fraction of the circle that the wedge takes up, because again, the total circle is 360. So first we find the fraction that the wedge takes up of the total circle, and then we just take that fraction and multiply it by the area of the circle, because, well, it's just a fraction of the circle, right? So it's just pi r squared times the fraction that the wedge takes up of the circle, and that's theta, which is the degree measure, divided by 360. So
And that represents the area of this piece of pie of the circle.
yeah.
So I have a question.
Yep.
So theta is mostly just like a variable.
Yeah. Think of it as like X, or it's
Yeah,
just a fancy variable. I don't know why they use it.
It's used a
It's
lot
just-
in geometry,
Yeah.
especially for like degree measures. I don't know why, but especially in like trigonometry, like
Yeah.
they use a theta for almost every time.
Yeah. I don't know why. It's just like that.
I think it's just to make it like harder for everyone so that people don't want to do math.
Yeah.
Don't get intimidated by it. All right.
Okay.
Okay, so let's suppose the AMC gives you an equilateral triangle. So a triangle with 3 equal degree measures, which is 60. And yeah, it's just a normal Greek letter. And then 3 equal side lengths. And let's suppose it gives you the side length like S, right? So how would you find the area of this? So since we don't have the height, we have the base, but we don't have the height. We can't use base times height divided by 2. Well, I mean, we can, but we haven't learned that proof yet. We'll go over that proof in next class. We'll go over the proof of this formula. So you would do side squared, and then you multiply that by radical 3, and you divide by 4. I know this seems really, really obscure, but we'll go over the proof next class, and it's actually pretty.
Wait, okay. How would you multiply by radical 3? Like, I don't know what how.
You don't need to know
Radical
radical 3.
is
You can
giant.
just express it as like 4 radical 3 divided by 4.
Yeah. The
something.
radical 3 can just stay radical 3 because you can't really simplify.
Like radical 3 is like 1.71, but you don't need to know that. Like,
Yeah.
like if S is 2, you can just do 4 radical 3 divided by 4, which simplifies to radical 3.
But then how would I do Radical 3 divided by 4.
You don't need to do that. Just
Okay.
Yeah,
keep it.
just leave radical 3 the way it is. You don't need to deal with it. Pretend it's like a variable that you just leave.
Yeah. So you don't need to.
So,
The question will always be, the answer will always be in terms of radical 3.
Yeah,
It'll say express your answer in terms of like a
in
simple,
simplest radical form.
yeah, the simplest radical form. So just keep it as radical 3. If you're doing like 3 square, if the side length is 3, then you would do 3 squared radical 3 divided by 4. So the answer is just 9 radical 3 divided by 4. That's it. There's nothing else. You don't need to simplify it from there. Yeah.
And that would be your final answer.
okay.
Okay, are there other questions? Oop.
Yeah. So this is an example.
Yeah, for this one, the side length of the equilateral triangle is 5, and we know our formula is s squared, side length squared times square root of 3 over 4. So again, we just plug it into the formula. 5 squared times square root of 3 divided by 4. That's just 25 square root of 3 over 4. And we don't do anything with it after that because we can't really simplify it. It's just 25 square root
Yeah.
of 3 over
We
4.
don't want to write it as a decimal.
Yeah.
In AMC, your two enemies, well, there's a couple of enemies, but one is radicals, but in this case, the answer is in terms of radicals. 2 is fractions, and then 3 is decimals. Well, I know this is a bad example because the answer has both a radical and a fraction, but in my opinion, decimals are worse than both of those, just use a fraction.
Yeah.
So we want to avoid something, so we can just keep it like that.
Okay, I think you guys now get the chance to do some stuff with equilateral triangles. So, yeah, find the area of, oh, you want to say something?
Yeah,
Job?
first 3 answers get a point, and then if somebody wants to explain, you also get a point.
Okay,
Okay,
find the
so
area of an equilateral triangle with a perimeter of 12.
Wait, did I do it correctly?
we can't say.
Okay.
Gotta wait till some more people answer.
So first 3 correct answers. All right. Okay, so perimeter of 12. So then
Oh, wait, I did it wrong.
if you got it right, we're not gonna let you explain just because we want other people to get the chance. All right, I think. Okay, there's a lot of people participating, which is good. I'm not. All right, let me see what the first 3 correct answers were. Okay, there's so many answers. Oh God. Also, for future reference, if you want to write a radical, you can just do this like that instead of typing out radical. That stands for square root. In math, that's like the math text for square root. So that's SQRT. Yeah, so okay, and you can stop typing your answers now. There's like, several people typing their answers like 4 times. Yeah. Okay, let me find the first 3 correct answers.
I can actually, if someone, wait, should I ask a volunteer to explain, or should I just call on someone?
1, 2, 3. Okay. I got it. Yeah, does anybody want to explain?
I mean, I think I got the correct answer, but I might have done it like
You got it
calculated
right.
wrong.
If you were one of the first 3 people, you can.
But yeah, you did get it right on it.
I did. Okay. So what I did at first is I only found the area of the height. Like I only found the height. So then I realized I was wrong and I had to find the area. So what I did is I did a perimeter of 12, and there's 3 sides of a triangle, and since it's an equilateral triangle, all 3 sides have to be equal. So I did 12 divided by 3. That's the base. So to find the height, I did 4 squared times square root of 3 divided by 4. Or I mean square root of 3 divided by 4, which would just be 4 square root of 3.
Yeah, that's right.
And then from there,
Oh, wait,
Yeah.
Oh, wait.
wait. No, that's solving for the area. So the area is 4 square root of 3 divided. It is 4 square root of 3. That's not the height, that's the area.
Oh.
Yeah, so that formula wasn't for the height, it's for the area.
oh,
Yeah.
I didn't know that. I can understand.
Oh, that's okay. All right. Does everybody understand?
Yeah. So then, is it possible to find the length using it?
The height? Yeah,
We're going to go over that next
we're gonna go over
class.
that
Okay.
next class. There's a proof for it, but we don't want to do that this class because it's kind of off topic. Well, but that will be on the topic for next class. You can use Pythagorean theorem, but the proof we're going to be using is something else. I think, yeah.
Yeah. Okay, let's do a second problem. Find the side length of an equilateral triangle that has an area of the square root of 3. So this time you need to work backwards a little bit. So instead of finding the side length, or sorry, instead of finding the area, we're now looking for the side length. Okay, we've got some answers.
Make sure you read the problem correctly.
Okay. All right, so does someone want to explain this question? Advika, I see you volunteer in the chat, so you can.
Okay, so to solve this, since we know that the area is the square root of 3, I knew that this had to be a side length that canceled out with 4. So at first I thought it would be 4, but then I realized that it would become 16 times the square root of 3 divided by 4, or 4 square root of 3. So then I remembered that 2 squared is equal to 4. So that's how I got my answer.
Yeah, that's right.
We just did algebra, so we just did 4 radical 3 equals side squared radical 3. So side squared equals 4, so side equals 2.
Yep, nice. Okay, one more. This one's a little bit different, but think about what a hexagon is made up of. Find the area of a regular hexagon with a side length of 2.
This is a little bit trickier, but I recommend drawing it and splitting it up. Those are my 2 hints.
Yeah. That's a terrible hexagon I drew.
And it's a regular hexagon. Does everybody know what regular hexagon means?
Hexagon with like equal sides.
equal angle measures.
Okay.
Equal sides, equal angle measures.
No, not equal sides, because some hexagons can have
No,
all
it's a
equal.
regular hexagon. Regular hexagons have equal sides and equal angles.
No, I'm pretty sure if it's regular, like it's side length. Oh wait, does side length matter? I'm pretty sure.
Yeah, they do.
Oh
Otherwise, this problem wouldn't work.
no, because I know some.
Oh, Vishal, you're supposed to figure out the formula. Rashab gave y'all a hint.
Oh,
Right.
I think I know what the formula is. Do I have to like? Could I just say what the formula is? I think.
Just type it in the chat.
Okay.
A regular hexagon has all angles of 120 degrees. We can prove that later, I guess. So 120 divided by 2 equals what? 60. And 60 is the angle measure of an equilateral triangle. So if we draw a bunch of diagonals and split these angle measures into 2, we get 6 equilateral triangles. And so that makes a 6 s squared radical 3 divided by 4. So you just, plug and chug. Okay, let me look for the first correct answers. One, two. All right. Two. Two.
Sure, Harsh, you can explain.
Okay, so the area of a regular hexagon with a side length of 2, which means every side is 2, and that's the base of every equilateral triangle. So we would do 2 squared radical 3 divided by 4, which would be 4 square root 3 divided by 4, which would be 6 times square root 3, and that's it.
Yeah, that's great.
Yeah.
You explained perfectly. So yeah, hexagon is actually made up of just 6 equilateral triangles, and that is very helpful.
We have a lot of people have points, so that's good.
Are you guys keeping track of the points or?
Yes,
do you
I'm
have to
keeping
do
track of points.
that? Okay.
It's a little hard just because there's a lot of people.
They aren't right triangles, they're actually equilateral triangles. Because when you divide,
so-
when you draw a hexagon has an angle of 100 interior angle 120 degrees. So when you draw a diagonal, it's splitting that into 260-degree angles.
I don't know why it has a if you like, I know some people may be thinking, well, how are we supposed to know it has a angle measure of 120 degrees? Just look at the if you don't know that, you can look at just the center of the hexagon. So that revolution right there, it has 360 degrees, right? It's just a circle like in the center. So when you draw these diagonals through, you're splitting that 360 degrees into 6 individual pieces, and now you have 6 pieces of 60 degrees, right? Understood?
Yeah.
Okay.
Cool.
All right. I hope you guys understand how to get a hexagon, but now we're gonna just extend this to just any regular polygon. So there's a thing called in a regular polygon called an apothem, or I don't even know if I'm pronouncing it right, but basically it's the distance from the center of the polygon to the middle of one of its sides. So it's sort of like the radius of a circle, except it's like for a polygon instead.
Well,
Kind
you
of.
have to be very, you have to be careful that you don't connect the center of the regular polygon to one of the vertices.
Yeah, it's just the center here, center of one of the sides.
This is the midpoint of the side.
Yeah. So this apothem is sort of like the height for, like, if we now split this polygon up, this apothem is now basically like the height for one of these 5 triangles. And so so we can use that to find the area of a polygon. So the area of any regular polygon is 1/2 times the perimeter of the polygon times the length of its apothem. And where we got that is because, again, we have these like we can split the polygon up into pieces, right? And each of these pieces is a triangle. So we have the length of its side here. Then we have the apothem, which I'm going to use as h. So the area of one of these triangles would be 1/2 times the side length times height. So I'm just going to write 1/2 sh. So then, since we have 5 of these, we multiply it by 5. But 5 times the side length is actually just the perimeter of this hexagon. So it'd be 1/2 times the perimeter times the apothem.
Yeah, I mean, you can use this for like a square too. It's just for a square. You can just do
So
side.
let's explore. Wait, what do you mean by a regular polygon?
Regular? Oh,
okay,
sorry,
yeah,
you can
with
explain.
all sides and angles are the same. So a regular hexagon, like the thing in in the previous slide, a regular pentagon has 5 side lengths of the same length. A regular octagon has, it's like a stop sign, 8 of the same length. Amy, can you draw a regular octagon?
I'll try.
I'm not gonna ask you to draw a septagon because septagons are hard.
Yeah, this is my attempt at the
Yeah,
an
so-
octagon. Basically,
Yeah.
all the side lengths are the same.
All right, now draw a regular icosahedron. No, I'm joking.
No,
Oh.
that'd be hard.
How many sides does it have?
That's 20.
Yeah.
Decagon is 10. Dodecagon is 12. Octagon, nonagon, septagon, hexagon, pentagon.
Yeah, don't worry about memorizing all the big names though. Just know the basic shapes, like
Okay.
a square, a pentagon.
You basically just need to know octagon, decagon, pentagon, and hexagon. That's about it.
Yeah, and even then, they'll give you definitions for any shapes with more sides.
You don't even need it. They'll tell you.
Yeah.
The AMC is assuming that you only have knowledge until whatever grade level that is. For the AMCA, they're assuming you only have the knowledge until 8th grade math. You can solve every problem using that knowledge. It's just not convenient.
I had a question.
Yeah.
The you had written the 1/2 sh times s. Is that another formula?
Oh no, it's the same thing. I was just showing you how we got it.
It's SH times 5. That's what it.
Oh, 5.
Yeah. But that's just for like this example. It's just 1/2 SH times. It's
The
1/2
5 sides.
EH. Yeah.
Okay.
Is there a way to find the apothem?
Yeah, you can use Pythagorean theorem.
But we'll learn that next class. For this, we'll just usually give it the apothem length to you.
Okay.
And then, you know, when you're older, you can use trig, but I don't think we should teach trig.
Yeah.
Trig's gonna be way too many questions.
Okay, so so far we've been pretty straightforward with finding the area. However, sometimes they'll give you like a weird shape and they want you to find the area. So for these types of problems, you need to like combine the different area formulas and you either add them to each other or subtract them to find the area. So for example, Janicki won a digital art competition by creating the following artwork. If the dimensions are given, find out how much of the visible area of the image is in red.
This
So,
piece is
yeah.
worth $200,000.
Yeah, so the picture will consist of this part and this part. We just want to subtract this red part from inside of it. So you guys can try first. Oh, the base of the triangle is 6.
It says it.
don't forget about this little thing up here. I have no idea what this circle is supposed to represent.
Can't believe you've been in digital or competition with that.
Yeah, I don't know.
Janiki is 4 years old.
Yeah, it must be like for like kindergartners or preschoolers.
I feel like somebody could beat that.
Yeah.
A
I
lot of
think you
people
can make
could.
them like
Like it's so
2
bland.
seconds.
It has that many colors. Like look at it. It needs to be more interesting.
Okay.
Vishwa, give the answer in terms of pi. It's easy.
Okay. Let's walk through each of these shapes. So first we have this triangle, right? So the triangle has a base of 6 and a height of 10. So the area of the triangle would just be 1/2 times 6 times 10, that's 30. Then the semicircle has a diameter of 4. So that means its radius is 2. So 1/2, but since just half a circle, you have to divide by 2. So it'd be 1/2 times 2 squared times pi. So that'd be just 2 pi, right? And then finally, we have on this bite circle. This has a diameter of 2. So that means it just has a radius of 1. So the area would be 1 squared times pi, which is just pi. So finally, since we want the area that is not red, we do 30 and then we do 30 plus the area. We add up all the areas that aren't red, but then subtract the areas that are red. So we do 30 plus pi minus 2 pi. So that is actually 30 minus pi. I think some of you guys either like forgot that this is actually the diameter and not the radius, or you forgot that this circle existed, because I saw a lot of you got an answer that you would have gotten if you didn't add in this circle. So yeah.
Stop expressing it in decimals.
Yeah.
AMC doesn't allow calculator.
Yeah.
Or if you did that by hand, but in that case, that's pretty nice.
Okay, let's skip this one just because.
Yeah, I don't like that question.
Yeah. Okay. I think we can just do the Jamboard now. So here you go, everyone. That's the Jamboard. Okay, Rashad, do you want to go through like one at a time, or do you just want to let everyone loose?
Let everyone loose.
All right, so everyone, just spend a couple of minutes doing slides 1 through 7. Don't go past slide 8 because that's for the second half of the presentation. Yeah, for all of these, for slides 1 through 7, just find the area. And yeah, I mean, you can just do whatever on the Jamboard as long as you're not like destroying it, I guess. Yeah.
for diagonal, is it, I mean, for the kite or rhombus, isn't it diagonal times 1/2?
Yes.
Okay. Is it diagonal plus diagonal or diagonal times diagonal?
It would be times. Think about it like two triangles.
Thank you.
You guys are speedy. Honestly, I feel like this piece of artwork would have beaten the one that was in the slides.
Very much.
Yeah. This looks like some kind of thing that you would like make with salad or something.
It seems to something you make on Desmos.
Oh
I have a
yeah.
question. So,
Yeah.
like the 24 height, just showing the circle height.
Yes, circle diameter. And then the 30 height is for the square frame. Remember, it's the visible green area. So in fact, this, and this, they would be subtracting from the green area because the stuff that's behind there isn't visible. Okay. If you forget the polygon formula, what you can do is split up the polygon into triangles and work from there because it's the same thing. So for the polygon formula, it would be the apothem times the perimeter times 1/2.
It was 1/2 times apothem times perimeter.
Okay, hopefully you guys are starting to wind down. Don't get too caught up on the smiley face question, because yeah, just because. All right. Rashad, do you want to call on people to explain, or should we explain?
If anybody wants to volunteer, they can volunteer. Otherwise, we can explain.
Can I explain the smile, like the smile face one?
Sure. Just we're gonna start from the first one and work from there.
I can
Okay.
if no one else wants to.
So does someone want to, actually, I see Shran put, can I explain in his answer? So sure, go ahead. You can explain the first one. Shran.
Okay.
Okay.
So, wait, let me just open it. Now, there are two ways to do this. Now, one is the really slow and not fun way of using by drawing a line here and solving the area of both of these areas. But what I did was I duplicated this shape and flipped it over and attached it to this side. Like wait, can I draw? Okay. Did this. Like something like this. Okay, it's not exactly the same because this is a little bit smaller than the 5, but it still like works as a diagram. So then this is 5, right? And this is 10.
So you like
So now what I did was I did 10 times 15, but I have to divide by 2 because this is not an actual shape, right? It's only this. So it became 5 times 15, and 5 times 15 is 75. So that's how I got 75
very interesting.
square units.
Okay, that's a good way. I mean, that's essentially the same thing as, so yeah, I'm glad you did it that way. Yeah, okay.
Do you understand? Okay, I'm going to take that as a yes.
Yeah.
Okay, I got a private. Somebody can explain slide 2. Yeah, sure. Go ahead. It was Tanisha.
Yeah.
Oh, no, wait. She wants to do the second question.
Yeah.
So she'll do the second question. Does anybody want to do the first question?
I'll do it, I guess.
Okay, cool. All right, wait, let me give
For
you
the
the
first question, it's very easy. It's just you add up the base, which would be 30 plus 7, which is 10, and then you multiply it by 6, and then you multiply that by 1/2, which would just be 30.
Yep.
And I mean, yeah, it would be 30.
Yeah, nice job. Okay, Tanisha, you want to do the second question?
It would just do 8 times 3, which is 24. This was easy.
yeah, I think let's do it.
Okay. Does someone want to volunteer to explain the slide 3?
All right, Vishwa, go ahead.
So the first diagonal would be 10, and the second one would be 8. So 10 times 8 is 80, and then divide by 2 is 40.
Yeah. So you can probably figure by now, these questions aren't really that, they're not that hard.
Yeah. Actually, I don't know if we should go through all of them, Rashab, or should we just go through half of them?
I think we should go through half of them. I think for the most part, everybody got it.
Okay, okay, I'm not sure we should go over this. Okay, maybe we should go over the smiley face one because that one's a little bit weird. Okay, let's just go through the smiley face one. I think someone volunteered to try to explain the smiley face one.
Yeah, I did.
Okay,
Wait.
go ahead.
Who's speaking?
So what I first did is I found the area of the green triangle. I mean, circle. And that would be 12 pi r.
Yep.
Yeah, I mean 12 squared pi. So then, which is 144 pi. So then I found the area of each of the blue circles, which was 16 pi. 16 pi, and then I multiplied that by 2 since there's 2 of them. So then I minus both of them from 144.
Yep.
And then I found the area of the red circle, which is like the mouth, and very faintly, I think it says 12 as its diameter, so it would be 6 pi squared.
Yep.
And then that is 36 pi minus not 36 pi. And then the area of the diagonal would be 8.
Wait, one thing. You forgot to do one thing. This is a half circle.
Oh yeah, so then you would divide that by 2, which would then be 18.
Yep.
Pi. And then you minus the rhombus, which would then be 16 divided by 2, which is 8. Because it'd be 4 times 4 divided by 2.
Mm-hmm.
Wait, there wouldn't be pi in the rhombus though.
Oh shoot, you're right. There.
And then you would find the area of the total white area of the white circle of the white area, I mean, and that would be 900. So then you just do 900 minus what was it again? 144 pi, because that's the only white area that's visible.
Yep.
And then you'd find and then you would do the answer to the top equation over the 900 minus 144 pi.
Yeah, I can just bring it all the way to the end. I think that's 94 pi minus 8 over 900 minus 144 pi. And
Yeah.
obviously this could be simplified, but I'm not going to do that right now.
With the pi, can the pi be canceled?
No, it would just stay
No.
there.
Okay.
Yeah, great job.
So why did we do 900 minus 144 pi underneath?
It's because it's asking for the ratio of the visible green area to the visible white area. So normally, the area of the entire frame is 900, but you actually can't see all the white area in the frame because some of it's covered by the face. So we have to subtract the area of the face, which is 144 pi.
So since we're finding the ratio, that's why we're dividing.
Yeah. Okay. Okay, maybe we should go back to the slides now because.
Yeah,
All right.
good idea.
Oh yeah. Oh my gosh, we're right on time. Rashab, look. Yeah. Okay, you guys get 5 minutes to basically do whatever you want. I'm gonna go to the bathroom.
Bye. Who is in the lead right now? I'm not gonna say. Haha. Does anybody have any questions not relating to the topic of today? Anything, AMC, math competition. Even if you want to ask like a question about me.
Do you know any math competitions that are going to happen soon?
That are gonna happen soon.
Yeah.
Most of them happen during the school year. Let me check. How are you in middle school?
Yeah.
Okay. Middle school, the main one's like math counts, I believe. I think this year the AMC is happening in November, which is interesting. Usually it's in February.
Yep, they are. In
Okay.
I think that's the soonest one. I mean, there's probably like some really small one before that, but I don't recommend doing like, I wouldn't say irrelevant, but in a sense, they are kind of like irrelevant. If you're doing it for like merit. Any other questions? Oh, we didn't do an icebreaker.
That's okay.
What are you drawing?
I have no idea. I just think it's cool.
I like this pen thing that Zoom does.
Yeah, I like it too.
Very useful. What if we just do an icebreaker right now?
Yeah, okay. We can do that.
And name a fun fact about yourself.
Yesterday, our neighbors had fireworks for 4th of July.
They were on fire? Oh, fireworks. Okay. I heard that wrong. But it's not even July.
Oh yeah, but it's gonna apparently it's gonna rain all next week or something. Let me check.
Yeah, it's raining all of this week. It's kind of sucky.
Yeah, okay. Originally it had more rain, but yeah. I think that's why they did it yesterday, even though it's over a week from 4th of July. I bet half the neighborhood was like, what?
You go to Mazik and you love rainy and cloudy days.
I like rainy and cloudy days too.
I only like rainy and cloudy days I like cloudy days more than rainy days. But
I don't like rainy days. I want it to either be cloudy or I want it to be thundering. Other people can draw on the board too. You guys, we should work together and make a drawing or something.
I hate it when it drizzles. You were born in California. I have a friend that was born in Ireland. He has an Irish passport.
Oh, cool.
Yeah. I think Amy knows him too.
Wait, do I?
Yes, you do.
Oh, I probably just don't know who you're talking about. Even though I probably know him or her.
You have a little brother. Oh, interesting. I'm an only child.
Okay, the timer's up and I couldn't tell at home. Okay, I'm gonna have to clear everything from the board.
Is anybody an 8th grader? I just want to know. Okay, I'm assuming that's a no. All right.
Oh, Montesvi? Oh, cool.
So are you going to be an 8th grader or are you going to come to manual? Or whichever high school you're going to?
Going to 8th. That's cool.
Alright. Perimeter is probably, I would say it's a little more trivial than area, just because the formulas for perimeter, they're not really formulas, because
Oops.
like you're adding up all the side lengths, if that makes sense, except for circumference. I don't know, like, how else you would approach that, like it's just the sum of all the side lengths.
Yeah, I mean, there's a couple of specialized formulas for like circles and some other weird shapes, but other than that, I mean, you just gotta find your way to get the side lines, and you just add them up.
I don't really. I hate excessive formula use. Because it's just like, it just shows that you cold memorize formulas, which I mean, I like, you can, it gets questions right, but at the same time, you can just solve it without a formula,
Yeah. So these are pretty trivial then. I mean, squares, you add all the sides up. Rectangles, you add all the sides up. Regular n-gons, you just add all them up, or you just do the number of sides times the length of each side. So yeah. Now for circles, circle perimeter is called the circumference. And basically, the circumference of a circle is the diameter of the circle times pi, or that's the same thing as 2 times the radius times pi.
And about why people put 2 pi r. Like, you can just put diameter times pi.
Yeah.
Wait, who's putting all of these, like?
Sorry,
Oh,
I just discovered that. Okay. Yeah, so yeah, circumference is 2 pi r, or the diameter times pi.
yeah. That's about it.
Yay, back to the Jamboard. Same Jamboard as before, but if you need the link, I'm gonna shoot that into the chat.
Woohoo. Jamboards are so fun.
Yeah. Okay, now you can go beyond that big warning sign where it says do not move ahead. Yeah, we're just basically doing the remaining 2 sides in the Jamboard for perimeter.
If you don't participate, I'm gonna delete your Minecraft account. No, I thought we had conflicting answers. I was so excited. I will delete your Minecraft account. Yes. Because I have abilities.
Hack the servers or
I
something.
know a guy that works at Mojang. That's what it is, right? Mojang? Mojang. Wait, didn't Minecraft buy Mojang? Yeah, Satya Nadella is my best friend.
That was fairly fast,
Yeah.
but it was fun.
You should be able to solve it fast. I think I'll be more surprised if it took you a long time.
Yeah, I mean, the formulas took like 1 or 2 minutes.
But like, the AMC is not gonna ask you questions like this. I hope you guys,
Right.
maybe like number 1.
Yeah, number 1 is like this, and then all the other ones are just like,
It escalates so quickly.
yeah.
Like, it says like 1 through 5, you solve it, you're like, oh, this is easy. This is so easy. And then 5 to 10, you're like, okay, it's a little bit trickier, but I'm still doing fine. And then it like escalates so fast.
And it's like by 18 and 19, you're starting to like struggle a little bit. At least for me, I start getting a little bit.
You're like, well, no, like you get to like 16, you're like, this one's hard, I'll just skip it, And then you get to 17, you're like, this one's a little tricky, I'll skip it too. And then 18, you're like, oh, I have to skip this one too.
And then it's like,
18,
and then like 20 through 25 are just like, I'm
They're
not
just-
gonna try it. Though actually for last year, it was actually like 20 through 25 weren't as hard.
Last year, MMA, which is the company that makes the AMC, they just punished everyone, because I feel like what they did was they put the questions from 20 through 25 and they put it in 15 through 20's place. So when you get to like number 17, it's like really, really hard, right? But like in your mind, it's like, oh, it's only number 17. I should try to solve it, you know? And
Yeah.
number 25 was like honestly not even that hard, you know?
Yeah.
So
So
you're trying to solve all
that's
of these
kind of,
questions that are way harder than the last ones. They're supposed to be in the end, but in your mind, it's like, you know, it's an earlier problem number. I should be able to solve it. So it was not fun.
It sounds as if like it's always just the people who aren't like actually school just always want you to fail. But then it's like at school, like K-prep and everything like that, they don't want you to fail. They just kind of want to test you, but they're the AMC and all math competitions just want you to fail.
I mean, they kind of want to, I mean, maybe they don't purposely want you to fail, but it sometimes does feel like that.
The harder it is, the more it promotes their like how important it is, you know?
Okay, it looks like you guys have gotten the hang of perimeter. I think we can just go over these quickly. Does someone want to explain slide 9's problems?
Could I?
Sure, go ahead.
So can I do both or just one?
I mean, whichever ones you want to.
Okay, so first, like for the second one, the circle one, since it has an area of 64 pi, that means it's and the formula for that is the radius squared times pi. So it's radius squared is equal to 64, or the radius is equal to 8. And then to find the diameter, we just multiply that by 2, so it becomes 16 pi. And then for the equilateral triangle, if it has a side length of 4, you just have to multiply by 3 since it's going to be equal and it's a triangle, so it becomes 12.
Yep. Yeah, pretty easy. Okay, nice job. Does someone also want to do slide 10 quickly?
Yeah, these are pretty straightforward.
Yeah,
Hopefully,
honestly, sure, you go ahead.
wow, nobody raises.
Since the area of the square is 36, I found the square root to get 6.
Yep,
And I multiplied that by 4 to get 24.
yep. Easy peasy.
Yeah, and then the second question, the perimeter of the square is 52, so I divided it by 4 to get 13.
Yeah, very, very basic.
Yay. Okay. Looks like you guys know how to get the perimeter, some basic stuff. So
All right.
now,
Questions now? Let's
What?
go. No, I asked if we can move on to the fun questions now.
yeah, we're moving on to AMC8, and I think there's a couple of mathematical problems. So yeah, we're moving on to like the real stuff now.
The fun questions.
Yeah. All
No,
right.
Fun to explain. Well, I mean, this one's actually kind of, it's not that hard, but
Yeah, it does. It's a little bit. I mean, I don't know how to describe it. It's like,
no, like, you know, I'm talking about like the, wait, let me go to the AMC questions. You know,
Yeah,
I'm
you guys
excited
can-
for the question, like the fourth AMC question,
yeah,
the ninth AMC question. But no, the ninth one's not that interesting.
we might even. Okay, hopefully we can get that far.
I-
Anyway, you guys can just solve it, and once you're done, you can put it in the chat, and we'll call on someone to
Well, the
explain.
18th one is really nice. I'm really rocking with that one. I like that. I like an 18. Slide number. I don't even know anymore.
Yeah, I can't really see it because I'm presenting, so yeah,
Oh,
I can't skip ahead to check.
it's like the. Actually, I'm not gonna describe it. Oh, number 11 is a good one too. Can we just do like ones?
Should we include units?
You don't have to. Generally, Generally, the units will already be included in the answers for like math counts and AMCs. But if you want
Okay.
to, it's a good habit.
Okay.
Amy is an expert at drawing clouds. All right, we have some answers. Very
Yes,
good.
we have a lot.
Very good, very good. All right, let me see who answered first. 1, 2, 3, 4. Oh God, there's so many. Advocate, you may not explain. I'm not like mad at you. It's just that you were one of the first 3 people to answer, so I just don't want you to explain.
Yeah, there's someone who is not like the first 3 people. Oh wait, let's check Vishwa.
Yeah, Vishwa is good to explain.
All right, you can explain.
So if the smaller side is 5 feet, then CB would be 10 because 5 plus 5 is 10.
Wait, what?
And then that smaller section of DC would be 5. And then rectangle that's like lengthwise with the 2 other rectangle shorter sides meeting its longer side, that would be 10. So then the remaining side of DC would be 10. So 10 plus 5, 15, 15 times 10, 150.
Yay. Yep,
Yeah.
that's perfect.
Augers.
Yeah.
Yep.
I mean, all the math competition questions are sort of similar in
Fire
style.
Kangaroo. No, AMC questions are harder than Math Kangaroo.
Yeah.
This is like a number, what, 11, 10?
Probably. I don't. This might be from AMC 8 though, so it might actually be a little bit.
So these are AMC8 problems?
AMC 8 or AMC 10. I don't exactly know which tests they came from, but they are AMC problems. Wait, is this on AMC or this math counts?
Any problem? That'd be interesting. Yeah, what if we give them an Amy problem? That would be kind of overwhelming. Not
Yeah,
kind
AIME problems are
of,
just.
it's gonna be torture. A lot of banana questions in math counts. Like there are, but yeah, there are.
Yeah.
They look at some questions about fruits, and on purpose they'll make like, if they have questions with multiple people, they'll make like the names
The
like
A, B,
even
C,
for, like
D.
really bad names. They'll make the names like so similar so that you get confused. Like
Oh
they'll
yeah. Sometimes it's like they all start with B's.
Dally,
But
like
you can't. It's so hard to assign variables to the names because they all start with the same letter.
or they'll make the names like Sally, Dally, and Jout. You know,
Yeah.
so they all sound the same. So like you get mixed up. That's what I'm telling you. Competitions want you to fail.
Oh, by the way, if you're stuck on this problem, just do note that these lines actually intersect at the center of the rectangle. The reason is because
You should give like one thing. Well, these math competitions say not to scale. Everything is to scale. Like I know you may not believe that, like 99.9% of the time, everything's to scale. Okay. Like there have been problems where I would have been stumped. So I took my fingers and I used my fingers as like a measurement tool, and I like counted using my fingers, and like you know, it like made like ratios, you know, like everything's to scale.
yeah, most of the time it is roughly to scale at least.
Yeah,
I mean,
99% of the time it's to scale because they make all these things using the computer software, right?
yeah.
And when you use it using a computer software, the computer is going to make everything to scale, right? Everything is going to be pretty accurate.
Oh, wait a second. Did anyone solve this problem? Oh, okay. I see you have an answer.
Okay, let me check what the right answer is so I know. Oh God. Very interesting.
Okay, let's check your answers. Notice that it's asking for the shaded region, right? And the area of the whole rectangle is probably like around 40.
Got it like this. The area of the rectangle is 8 times 5, which is 4, right? Now look at the area of the shaded region, okay? And now, you should, it's less than half, It's
Definitely less than half of the area of the.
it's less than a fourth. I think. Yeah, it's less than a fourth.
Yeah.
It's less than a third of the area. So think about it like that, logically, you know.
Also, if you guys want, I can add another hint.
Yeah,
So-
just add a line to.
Yeah, I'm gonna try. I'm checking if there's a line tool. All right, I'll draw a line. Okay, so if you draw a line connecting both sides, basically what you have now is that you have one triangle, two triangles, three triangles, four triangles. Now you can use a triangle formula.
Or you can solve for the other figures.
Or you could solve for these guys. You could solve for this one, and this one. Either way, yeah.
You could literally, you don't even have to use the entire figure. Just use symmetry. Well, would you guys be interested in doing a countdown round? Like sometime?
Countdown round.
All right, cool.
No, yes.
No,
We
Well,
should have a vote. Everyone put yes or no, or maybe. If you're not sure, you can put maybe.
you see,
But like,
if you guys remember, if you guys were in an Omega in the previous session, I did countdown round like me and Gopal, and like we had a blast. Like I remember who won. We literally had so much fun. I think Anand won. No, Anand lost in like the finals. I don't remember. Was it Aryan? No, Aryan lost in the finals too. No, Aryan won. I don't remember.
Yeah, I
But
think it was either us. Wait, like, are you talking about the old Mathema?
yeah, the old Mathema.
Yeah, it was either Aryan or Asvika. I don't remember. Asvika. Yeah, here, let me check.
Wait, do you have the bracket still?
No, I don't. But yeah, I'm pretty sure it was Aryan. I know I was third, and it was either Aryan or let me check. Yeah, I know who's in the top two though.
Oh, I know the top three. The top three were Aishwarya, Aryan, and Anand.
Yeah, I think Aryan won. Either her or Asvika.
okay, did anyone figure out this problem yet? If not, I think I'll just go through it. I don't think 14 is right. Let me just double check though.
Yeah, no, I can't figure it out. Maybe.
Yeah, 14 wouldn't be right. Kite, that wouldn't actually be a kite. And also, actually, would it be a kite?
Okay, so
No, it wouldn't be a kite.
let's solve it personally is find the area of the white space and subtract it from the total thing, the rectangle. Why did I say thing?
I would actually prefer to just directly find the area of the gray area, because if you notice, the gray area, I just split it into a couple of triangles. So the
Okay.
base of the triangle, it has a length of 1, right? And then the height of the triangle actually is this part, which is half of the length of this side. So the height of this triangle would be 4. And since it has a base of 1, then the area of this triangle would be 2. And because this triangle is the
So you
same,
do the same thing
this
for
would also be 2. And then this triangle over here is a little bit different. It still has a base of 1, but the height would be half of this side. So this would be a height of 5/2. So this triangle's area would be 5/4.
And so the other one's also 5/4. So now we just do 2 plus 2 plus 5/4 plus 5/4, which is, as minus V said in chat, A equals 6.5.
Yeah.
Cool. What problem number was this?
This for, I don't know. Ishani got these questions.
No, this question I got. I forgot.
Oh, you did? Oh, okay. I don't know.
I made this question. No, I didn't make it. I found this question.
Okay. Yeah. I don't
think
know which question, but I think it was sort of like,
It wasn't
Oh.
past 15. This isn't a past 15 question.
No. Okay, let's do this one. Number 3, point O is the center of regular octagon ABCDFGH, and X is the midpoint of side AB. What fraction of the octagon is shaded? And hint, hint, for this, you don't actually need to find the area. You just need to do
hint,
some thinking.
Splitting up is like in my opinion, there's two really good things to do in geometry problems. One is if you don't know what to do, draw random lines everywhere and see where that takes. Right? Draw perpendicular lines, parallel lines, lines with 60-degree angles, whatever, great lines. Another tip is, this is a little bit advanced.
Oh, this is very easy.
Yeah, this
Yeah.
one's
It's actually really easy once you figure it out. Wait, is this an AMC problem or a math count?
It's 3.5.
for 9 AMC question. It's not a hard one.
Okay. I think there was a math counts problem that was similar to this on the target round that I wasn't able to solve, but it's
Yeah.
actually really easy.
That was like a number 7 or 8.
Yeah.
Honestly, I like AMC more than math counts, but that might just be me.
I like math counts.
Like
It might be because I've been training a lot for
Can I
that. So.
explain how I got my answer?
Sure.
Like right now, or
I think you can show it now because it looks like some people have answered already.
I'm gonna give
so
you
what I did is there's 8 triangles that make up an octagon, and each triangle. I mean, what am I saying? Each point is like perfectly on one point or between 2 points, perfectly. So then you can just count how many triangles fit in the gray area overall, like all triangles, it would be 8. So it'd be 3.5 triangles that fit in the gray area, and then 8 triangles overall, which is just 7/16.
Yeah. That's exactly how you do it.
got it. Yeah. Does everybody understand? Next question.
Oops. Oh, shoot.
Oh.
Okay, it should be out right now. Okay. Yeah, I think this is an interesting problem. Rectangle ABCD has sides CD is 3 and DA is 5. A circle of radius 1 is centered at A, a circle of radius 2 is centered at B, and a circle of radius 3 is centered at C. What is the area inside of the rectangle but outside of the circle? So in other words, this weird shaped area over here.
If you ever see a thing like a shape like that, always any shape with curves that you're trying to solve the area for, never like try to directly find the area for it. Always try to split it up, like or subtract it from a larger figure.
Yeah, you have to subtract it from the larger figure. Don't actually be trying to like draw lines and find this weird area because that's like impossible.
Yeah.
Without like calculus or something.
In
But
general, for questions
bad.
like not this
Yeah.
one, in general geometry questions is like to assume that everything is on a coordinate plane. So put it on a coordinate plane and then solve.
well, for this one, you don't even need a coordinate plane.
For this, I'm not saying for this question, but just in like general.
Yeah.
And kind of give everything points, like coordinate points, and then solve using, slope intercept forms and
Yeah.
stuff.
That usually.
In like
Although
dash.
I try to avoid resorting to that unless if like I literally can't find any other way.
That's like my last,
Yeah.
thing. But like the thing is, it takes a long time, but it works.
Yeah.
It's good for target questions.
Oh, cool. I didn't know you could do this.
Amy is spending this entire class experimenting with different Zoom marker tools. All right, we have 4 answers. Very nice.
Yeah.
Should we go over?
Sure. Maybe we should get Arjun to explain if he's okay with that.
Okay. So I just found the area of each circle and then got a fourth of it. So for C, it would be 9 pi, and then I just divided 9 by 4, which was 2.25. And then for B, I got 4 pi, so then I just added 1, so it was 3.25. And then for A, it was just pi, so it's just 1/4 pi, or just 0.25. So then I got the entire rectangle, which was 15 minus, and then the 3.5 pi.
Very nice.
Yep. Yeah, so for these questions, just like Arjun did, you just need to find the area of these quarter circles and then subtract it from the area of the rectangle.
Pretty straightforward.
Yeah. Okay, this problem.
So
Basically in this diagram, all angles are right angles. And the lengths of the sides are given in centimeters. Note the diagram is not the scale. What is the length of X in centimeters? It basically is the scale. Like literally, if you draw, like look, this is the length of 1, right? So then this just happens to be almost exactly the length of 2. And then this would also almost be exactly the length of 2. And that also happens to be almost exactly, yeah, basically it is the scale.
The scale is just, they always say not to scale, but it's always to scale.
Maybe they just say not to scale. So like,
So that you don't guess. I mean, I can look at it and I can guess.
yeah.
And honestly, probably get it right. Like look at 6 and then look at X and then look at 1. Exactly. The answer is 5. You can guess. Oh God, there's so many people.
I bet a lot of people just basically approximated the value of X.
But I mean, that's fine because you get the right answer.
Yeah.
All I did is that like I saw that 1, and then I saw like the part where X is, if you make a line on that rectangle. No, like on the bottom, like where the 2 is completely horizontal.
I don't know which part you're talking about.
Like horizontal.
Here.
Yes.
Okay.
Okay, that's not horizontal.
I tried.
Well, anyway,
I thought you were.
What you can do is you can find the vertical side lengths. It for the right side it would be 6 plus 1 plus 2 plus 1 on the right side, and on the left side it would be X plus 2 plus 1 plus 1 plus 1.
Yeah.
Yeah,
That's
and then you can find the difference.
math way of doing it.
Yeah.
If I were to do
That's the correct way.
X,
but-
not X is 5.
Yeah.
Look at it. You know? Like, you look at the length of 6, and then you see X is a little bit less than 6, and then you look at the length of 1, and X is about 1 less than 6. So what's 6 minus 1? 5. Wow.
Yeah.
Easy.
Okay. This question. I feel like I've seen this one before.
It must be so annoying. I don't like questions like these.
2 circles share the same center. They have radii. Radii is the plural for radius.
Lap running questions.
What is an aardvark?
These aren't lap running questions. This is not, I don't know. Wait, actually, let me look up an aardvark is.
Like, what am I trying to find here?
An aardvark is an animal.
I didn't know they ran laps. Okay. Basically, an aardvark runs along the path shown. It starts at A and ends at K. So we wanted to find the length of the path it ran. So basically, this plus this. Oh shoot. Let's try again. This plus this plus this plus this plus this plus this.
Okay, so you need to find the overall circumference of both of them. And then you need to, I mean, you could just do the diameter of the inner circle and half the circumference of the outer and inner circle.
I mean, I don't know.
Because if you just think about it with scale, you don't even find like the little two middle lines because they're about the inner circle's length.
Yeah.
No, Amy, I hate those labyrinth questions where it's like
Yeah, I don't like those either because
Bob is running counterclockwise at this speed, and then Joe is running clockwise at this speed, and then
yeah, when will they pass each other for like the third time or something?
yeah, like, well, after how many seconds do they meet for the third time? Those questions are so AIDS.
Yeah. I don't like those either.
I have to go in- Wait, like, do I let you handle the points? Because I shared the spreadsheet with you.
Sure, I'll just do it on my phone while everyone else is working.
Don't tell them who has how many points.
Yeah, I mean,
I'm
let me
being
see.
generous with these harder questions just because they're all answering it fairly fast.
Yeah. Guys, be careful. Just a note. When you have like, you might get something where it's like something pi plus something. So in that case, just leave it in that form, but make sure you don't mix up the term that has the pi on it and the term that doesn't have the pi on it. Yeah. So for this case, he has to leave, I think. I'm not exactly sure why. I think he has to like volunteer. By the way, he's doing like these lessons at his mom's hospital. So I think he has to like go or something. Okay, I see a lot of you guys got 60. Okay. The answer was 20 pi plus 40. So just note that whenever you have like something where both of the term, where you have two different terms, you have one term that has a pi in it, right? And then one term that doesn't have pi in it. In that case, just leave it this way. Keep these terms separate. Don't be like adding up these coefficients to get 60 because you can't do that. Treat pi like it's a variable. So it would just be 20 pi plus 40. So does someone want to actually Vishwa? Do you want to explain? Because I see you put some stuff in the chat.
Yeah, I can explain.
Okay.
So, if the bigger circle has a radius of 20 meters, then the whole, like the diameter would be 40. So circumference would be 40 pi. And if you take a fourth of that, that's 10 pi.
Mm-hmm.
And then it goes the distance between the A circumference and B circumference, like the between, yeah, that's also 10.
Yep.
And, the circumference of the smaller one is well, the diameter is 10 because 5 plus 5, 10. So the circumference would be 10 pi, and then take wait, no, it would be 20, and then take a fourth of that, and that's 5 pi.
Yep.
And then you add 20, the diameter, and then you add another 5 pi, and then you add another 10.
Yep, that's exactly how you do it. Basically, you just take the components and add them up one by one. However, if you didn't want to add them up one by one, what you could do is that you could just notice that all of the curved paths, so like these smaller curved paths are actually just half the circumference of this smaller circle. And so you could just get half the circumference of the smaller circle right away. Also, these straight paths add up to just be one straight line across the diameter of the larger circle. So you could also just get 40 from there. And then finally, you could just get one fourth of the circumference of the larger circle and just take that from there. That way you don't have to add them up one by one. So if you're in like a time situation, you could do it that way.
I had a question. Why didn't we do all pi? Like, why is it like, how do you get 40?
The 40 comes from these straight paths. Since these straight paths aren't in terms of pi. Remember that pi only comes from when you get the area or the circumference of a circle. However, these are just, I guess you could say, normal numbers. They're not in terms of pi. These are just numbers. So this would just be 10, this would just be 20, and this would just be 10. And there's no pi. So that's why you actually have like 20 pi plus 40, but the 40 doesn't have a pi in it because it's just numbers. Okay. Does anyone have any questions? All right. Okay, let's do this one, and then we might be able to push in another question or maybe two, but after that we have a Kahoot. So yeah. If I'm on my phone, it's because I'm updating the points. So yeah. Yeah, AMC problems, all AMC problems are actually multiple choice. The previous AMC problems we had in these slides didn't have the multiple choice just because we didn't want to include it. But normally they have like 5 choices. They have A, B, C, D, and E, and you just choose one of the choices. So that makes it a little bit easier when you're solving problems, because if you get an answer that's not one of the choices, then you know that you've done something wrong. Okay, what are the different areas you got for each of these shapes? So what did you get for A, B, and C? Okay, for A and B, I think all you guys pretty much got the right answer. And in fact, A and B are the same. For A, you have a square, and a square, it has a side length of 2, so the square has an area of 4. And the circle, of course, has a diameter of 2, so that means it has a radius of 1. So the area would just be 1 squared times pi, which is pi. So the area of the shaded region for A would be 4 minus pi. For B, which is kind of interesting, it actually has the exact same area. And the reason is because each of these 4 circles has a radius of 1/2. So 1/2 squared times pi would be the area of one of these circles. But if you multiply by 4, that's just pi again. So it'd be 4 minus pi. So A and B have the same area. However, C is a little bit different because obviously the square is inside the circle and the circle's instead of the opposite way around. So in order to get the area of the shaded region, we have to get the area of the square. And so in order to do that, we have the center of the circle, right? And so we can draw 2 lines extending to the corners of the square. Those lines actually represent the radius of the circle because this is from the center to the edge of the circle. So the radius of the circle is 1. However, so that means the area of the circle is 1 squared times pi, which is pi. However, the area of the square, what you can notice is that we basically just made a little triangle here, right? And this triangle this is actually a right triangle. So this right triangle has side lengths of 1. So the area of this triangle would be 1 times 1 times 1/2. And then that would be 1/2, obviously. However, there's 4 of these triangles in this square. So if we multiply by 4, then basically the area of the square is 2. So the area of the shaded area for figure C would be the circle minus the square, which is just pi minus 2. And so pi minus 2 actually has a larger value than all the other. So pi minus 2 is greater than 4 minus pi. So the answer would actually just be C. Also, AMC, I think it's, wait, if you're asking about AMC 10 and 12, it's in November. I'm not sure when AMC 8 is.
But why is it pi minus 2 greater? Because like if you even do it by hand, so it's 4 minus 3.14, which is 1.6, and I don't know what the other one is. I think
4 minus 3.14 wouldn't actually be 1.6, it'd be 0.86.
Oh, that.
Yeah. Someone got E. How'd you get E? C would have an area that's greater than A and B, so. Because it is. I mean, you might think they're equal, but they're actually not, so. Huh. Yeah, okay. Are there questions about this? Okay, well, let's get to the Kahoot now because I just realized that we only have 10 minutes, so. Okay. All right, once I put the link in the, once I put the code in the chat, I'll look at the question in the chat because I can't see it right now. All right, so I think first place will get like, oops, I accidentally sent the code to just one person. Sorry, there. Let me see. Okay, let's say. Okay, first place will get how about this? First place will get 6 points. Second place will get 4 points. Third place will get 2 points. And then who's Rashab? I don't think that's actually Rashab, is it? Oh my gosh, and there's a not Sai. Okay.
I wonder who that is. It's also me though, because my name is Anand.
Okay. First place will get 6 points, second place will get 4 points, third place will get 2 points, and I think I can give the runners up each 1 point. It depends. Actually, I think I'll be nice. Just give the runners up 1 point. You guys should join quickly because we don't have much time. Sai's like, Sai's not even, wait. I know Sai's brother might be in this class. Winner at the end of Friday? I don't know yet. I mean, if you guys have suggestions, what do you guys want? Like, if you win, like, what do you guys want? Okay, maybe we should focus on the Kahoot. Okay, area of this rectangle. Actually, I think I'll just be giving points to the first, second, third. I might not give points to the runners up because I don't know if we have enough people to do that. Actually, I might. It depends. Yay! Okay, perfect score, first question. I'm glad none of you guys got that wrong. If you did, that would be a little bit sad. Okay, we can't really give money because we don't really have any money. Okay, perimeter of this figure. And by the way, you do have enough information to solve this problem. You just gotta use some logic, I think. Okay. I don't think
I didn't notice the time.
Yeah. Okay, I can show you guys. So basically, you see this side, this horizontal side has a length of 8, right? Well, also these two bottom sides perfectly line up with the top side, you see. So even though we don't know what these individual sides are, we know that this length, these two sides together also have a length of 8, right? Also, the same thing goes with this side that's marked 7. This side is 7. These two smaller sides over here, we don't know their lengths, but they perfectly line up with the 7 side. So we know that the sum of these two sides also must be 7. So the sum would be 8 plus 7 plus 8 plus 7, which is 30, which is the perimeter. Okay. All right, what is the area of a triangle with a base of 14 and a height of 18?
Oh, I have a strategy for this.
Oh. I mean, I guess I could ask you to share it, but I don't know if you'd actually want to share it.
No, I want to. I'm fine with sharing.
Okay.
So since we know that it's 1/2 times base times height, so we'd already divide by 2. So I did 14 times 9. So I already know that the ones place is gonna be a 6. So I just picked the answer that has a 6.
Oh, that's smart. But the thing is though, for some problems, that's a legitimate strategy. You can do that. There's nothing wrong with that. So yeah, I mean, that's perfectly fine. Okay. Nickname is in first place. All right, what's the area of the figure below? I hope I didn't make a mistake with this.
Kind of guessed. Like
That's
I could
okay.
fast enough. Like
How many questions are there?
I think there's 15. So we may need to hurry up a little bit. Basically, you split this
I
into
can't see in first place for 15.
We can do like 56 minus 12.
Oh yeah, or you could do that. Yeah, you could split this into 2 rectangles and do that, or you could do 56 and then subtract this. I actually didn't think of that. Nice. Okay, nickname is still in first place. Right. The dark circle has a diameter 18, the light circle has a diameter that's 1/3 that. Find the area of the shaded region. Okay, yeah, I made a mess. I think I made, okay, no, I didn't. I was kind of tired when I made this Kahoot. I had just woken up. Okay, yeah.
Yeah, I feel like the problem's going a bit too fast. Like I got there, but then like I had to guess because I only had like 1 second left. So if you give me like 1 extra second, I'd have gone there.
Yeah. Yeah, maybe I didn't give you guys enough time. Yep. Okay, I should, yeah. I mean, you guys are just, I can't change it right now, so I'm sorry. Yeah, you gotta be speedy. Okay, for this one, I think you guys got it. Most of you guys. Oh gosh. Okay, nickname is still in first place. All right, what's the area of an equilateral triangle with a side length of 5? I think we did this in class. I didn't mean, well, whatever, it's okay. Okay, it looks like some of you guys forgot to square the side length. Remember that the formula is squared 3/4, or the side length squared times the square root of 3/4.
And
So
you
you
had
have
2 and that's enough was multiplied by 2 or square root of 2.
yeah, yeah, it would be yeah, it's squared. Oh yikes! Someone winner AR overtook nickname. Okay, what's the side length of an equilateral triangle with an area of 16 square root of 3?
Side length 20.
I like that this is fast.
Some people like it, some people hate it.
I don't, yeah, no. I don't know how that, like how?
So
Yeah,
Oh, because 60, I keep thinking that 16 is the square of 64 because I just know 64 is related to 16. So I just keep on thinking it's the square, but it's not.
Yeah. Oh my gosh, what is this red wait, Arian, did you make a big rectangle or something? Are you trying to sabotage the Kahoot game by covering the screen so people can't see? I don't know. Okay. Actually, I don't know if it was actually Arian Ian. I actually don't know who did that. So if I just randomly called your name out, sorry. If you're not in first place. Okay, side length of 8, so it'd be 64. And then each of the little circles has a radius of 2. So wait, would it be? Okay, maybe my brain's not working right now.
It has a radius of 2. Yeah.
Okay,
so then
okay.
it becomes like 4 pi and then that times 4.
All right. Okay, rectangle consists of 2 congruent trapezoids and 2 congruent triangles. Find the area of the green region. You guys have 1 minute for this. There are many different ways to solve this problem. I'm going to like periodically give you hints. So at the 20-second mark, which already passed,
Is that saying 8 at the very top or?
Yes, it's 8. Okay. Some of you guys got it.
Oh,
Okay.
I'm wrong now.
All right, I'm gonna show the media thing. Okay, so basically for this one, you just need to, you actually just solve for the area of the triangles. You don't need to find the area of the trapezoid. So the length of this side would be 20 because there's 2 of the heights, so it'll be 2 times 10. And then the height of, this part, the height of the triangle will actually be 1 because they're congruent. And because we know this length is 6, so in order for them to be 8, both of the heights would be 1. So then you
That
can
kind of
just
looks
find
like
the area.
5.
5?
Yeah, the the 6 kind of look like a 5.
Oh, okay. Well, the middle part just says 6. So, yeah. Oh, okay. Okay. This is the same diagram. The green region has an area of 40. Find the heights of the trapezoids. This might be hard.
You kind of just gave us the answer.
No, this is a little bit different. This one has a different height. So it's not 10.
Oh. Nah.
Did you click 10?
Yeah.
Oh no.
It's the same, because you said it's the same diagram.
It's the same diagram, but with different dimensions. It's not to scale. This one is actually not to scale. Unlike those other types of math problems where they say it's not to scale, even though it is to scale. This one is legit not to scale. Okay. Okay. Half of you guys got it.
The
At least
last
half.
one had 10, and then if you double the area of the triangles, you can just double the height.
Yeah, essentially. Okay. The leaderboard shifted around. All right, we're a little bit over time, but that's okay. Find the area of the green region. Yeah, I don't know if I gave you guys enough time.
Yeah, I did it. I don't know about the.
Okay. Oh, actually, almost all you guys got it. Okay, that's pretty good. Yeah, you just get the total area, subtract the inside area. Okay, find the area of the arrow. By the way, the 2s represent those little things over here. If you can't read something, just tell me. Okay, yeah, this will be 80. You just find the area of the rectangle, add it to the little triangle.
It's literally impossible for me now to go up any placements.
Aw. Radius of circle whose area and circumference are the same. This one doesn't have an image because it doesn't need one. Okay, remember area of circle is pi r squared, and we want that to be equal to 2 pi r. A circle does exist like that. In fact, an area, a circle that has a radius of 2 will have an equal area and circumference. So the area of a circle with a radius 2 would be 4 pi, right? Because it's 2 squared times pi. So the circumference of a circle with a radius of 2 would have a diameter of 4. So the circumference would also be 4 pi. So they're the same. I think this did come up as a math counts problem once. So at least now you know. Okay, last one. Find the area of this regular dodecagon. Dodecagon's 12 sides. Okay, yeah, the answer would be 192. We don't have much time to go over it, so let's look at the podium, guys. Okay, whose nickname? Okay, good job, Vishwa. Okay, good job, winner AR. Who's winner AR and nickname?
It's me.
Oh, okay,
Evita is winner AR.
okay. Whose nickname? Okay,
Can I reveal a secret?
sure.
I was not Psy.
Oh, well, I mean, great job, not Sai.
He
Yeah.
was 5th and I was 4th.
Yeah. Wait, whose nickname? I can't give you points if I don't know who you are.
Does that mean I go to 3rd?
I think I'll just give. Wait, Anand and not Sai. You guys were 4th and 5th, right?
Yeah.
Okay.